So, our very first speaker is a man by the name of Vijay, and I met him via, I guess I met you via the Twitter storm that happened after this taxi data fiasco, if you don't know the full story, I wrote a really awesome blog post a little while ago about my experience foiling data from the Taxi and Limousine Commission. And you can read it at chriswong.com. I actually show you the FOIA request memo that I had to print out and sign my name on. But my experience wasn't actually that bad. I had to go down with a physical hard drive and get the data. And then for so long I had it, and a bunch of people were coming to the meetup and saying, can I get the data? And everyone was asking for it. And then finally, so many people asked for it, I was like, it's time. I need to share this data and stop being a data hoarder. And put it online, and within 48 hours, Vijay had figured something out very special about this data, and that's what he's going to tell you about right now.
Hey guys, how's it going? So as Chris said, Chris did a great job. He's supporting his his passion in life, which is getting data open, so people can take that data and do awesome stuff with it. And I think as a community, we have to be very cognizant of all the possible things that could happen, both good and bad, with data that are released. And I think it's on our shoulders to make sure that the people who work in areas that are responsible for this really understand the implications of what they're doing, so that we continue to have good access to data in the future. So I wrote this article on Medium. It was called On Taxis and Rainbows. It's a long and complicated story, but rainbows is not actually the right term for what I was doing, but I really liked the title, so I kept it. But I'm fixing it now. It's on taxis and lookup tables. So I'm trying to leave some time at the end for questions, but if you guys have anything that is confusing, let me know, because parts of this are a little technical. All right, so as Chris said, New York taxi data was released a while back, thanks to Chris Wong. He did a Freedom of Information request. It was awesome, 175 million records, 40 gigabytes approximately, something in that neighborhood of uncompressed data. And this is a huge victory for open data, because it shows all the cool things that the community can do when they get access to data. But as Chris said, to get it, you had to go talk to Chris, and Chris would copy it to your disk. And this was awesome, but kind of a little bit of a pain in the neck. And Chris had this great idea. He got together with people, put it up on a torrent, download links. This is awesome. All right, the fun has started. So if you look at the data, this is what it looks like. You have, well, first of all, before we even go there, having access to the data from a resource in a way that everyone on the internet can get access to it easily is something I think is very critical for the open data movement, and something I think Chris understands from this, and also from the stuff he does as his day job. And I think that's, there are multiple pieces that you have to have in order to have a functioning ecosystem. And I think the ability to quickly access the data for your own purposes is really important. So anyway, the data contain records like this, which is, you see some random string, another random string, and then a bunch of other stuff. So you can see there's some longitude and latitude stuff in there. There's start and end times. There is length of travel. But I want you to notice the first two columns. You'll see that there are random things, and they look kind of like random long characters that make no sense. And the first two columns are these things. And one is a unique ID for every taxi, and the other is a unique ID for every driver. So, if you know New York City, each taxi has an ID, and each driver has an ID. And they probably, they didn't want to release all the data with the names of the taxi drivers, or the IDs of the taxi drivers, the IDs of the cabs, because maybe, they thought that was a good idea. So they replaced it with this. But you could still track, you could do cool visualizations. You can still track one taxi cab as it does everything, because the same cab has the same number throughout the thing. This is a great idea. It's awesome for visualization. This is exactly what we do. And cool things followed. Look at this. This is an amazing thing that someone put together. It's beautiful. It shows, I had nothing to do with this. I found it on the internet. And you can zoom in and out. It shows all the various taxi routes that have been taken. It's a heat map. It's amazing. This is...
People keep giving me credit for that.
Yeah.
It's awesome, but it's also Eric Fisher is,
yeah.
I'm no Eric Fisher.
Eric Fisher is the man. So this is great. So this is exactly what we want to have happen with open data, right? Cool things, and potentially even things that can be profitable, things that can help people get better access to data. So someone, actually a friend of mine, in fact, Jason, on Reddit he did a bunch of data processing, and he's like, you know, this is really weird. I added up all the money made by all the different taxi drivers every day, right? And I sorted who are the most profitable taxi for every day. What's the most profitable taxi cab? And you look at this, and it's like there is some guy, right, who's making $8,000 a day consistently is the most amazing taxi driver ever, right? So like, what's going on? Is it some kind of Superman? Like, is he driving at 5 times the speed of light? What's going on? And there was rampant speculation. No one could figure it out. And so I started looking at it, like, who the hell is this guy? Like, what the hell is going on? So I started with this because I wanted to do a visualization just like everyone else. I'm like, I'm going to look at cool things, I'm going to check out neighborhoods. But then I was looking at this, like, who is this guy? Like, what's going on here? And so years ago, I'd say about 8, 9 years ago, I worked at Google. I was building infrastructure internally at Google. And one of the things I built was a system that is very complicated. It basically runs on every production machine at Google, and it synchronizes files across all these machines. And I had a bug in my code that was really bad. And instead of checksumming all the contents of the files, it was only checksumming the file size, right? But I didn't remember this. I just looked at this, and I was like, this looks familiar. And it's like, a random string shouldn't look familiar. This is like, I'm losing my mind, what's going on? So I tried to think, I was like, where have I seen this before? And then this happened. I was like, I wonder if it's just 0. And I wonder if they're using MD5s. And this is what happened. So it turns out that they're using a hashing function called MD5. Who doesn't know what a hashing function is? All right, great. Next slide, I'll explain it. So they're using a hashing function. Stay with me for a sec. And basically what they did was they took the value 0 and they put it through this thing, and then it generated this number, and that's what it is. And that's great. They hash all the values. So they took your taxi cab number, they hashed it, generated this random thing. That's great. So this is how they generated these IDs. So what's a hash, right? So this is exactly what you want to know. So hash it's a fast one-way function. So it's basically a function, like if you remember from math, there's like y equals x squared. That's a function. If x is 2, y is 4, right? And the cool thing about that function is if I tell you f of x equals x squared and f of x is 8 or f of x is 16, you can tell me x is 4 really easily. So it's a function. So it's a function like this for every time you have a specific input, it always generates the same output. And when you have different inputs, a hash function should generally generate different outputs, right? This is very useful in computer science. It's one of the most fundamental data structures and fundamental algorithms in computer science. So what's special about a hash function? Well, what's special is that going backwards is really hard. And there's a whole special class of functions where if I give you some value, you put it through the function, it gives you an output. If I give you the output and you don't know anything about the input, it is almost impossible to figure out what the input was. And this is a very important, for various fundamental reasons, it's important computer science property. And so like if I give you some random string like this, you have no idea what this is. And going backwards is extremely hard. So there are a number of things. So first of all, actually, MD5 is not a good thing to use for hashing anymore because MD5 is old and computers are really fast. So with the modern GPU, you can actually brute force it. So you can actually compute to a certain degree every possible value within some reasonable amount of time. So, but that's not what's wrong with this data. MD5 isn't it. The problem is, if you remember, if you don't know anything about the input, you cannot go backwards. But if you know stuff about the input and it's a relatively small range, you can try every possible input and see what the output is. So, for instance, if you hash people's names, like John is a pretty common name, so maybe you can just try John and see if that shows up anywhere in the output. And if it does, now you know what this corresponds to. And you can do this for anything you guess. This, you can get a lot of the data. But what they hashed was taxi IDs and medallion numbers, and that's very, very structured. Taxi numbers have 4 digits or 5 digits, and 5-digit numbers always start with a 5. And medallion numbers all look like this. So the question is, how many possible taxi numbers and medallions are there? Well, it's only about 20 million. And calculating an MD5 hash of 20 million things on a modern computer is less than a minute. So it's pretty easy, right? So you can build a table that says, for all the possible values, what is the MD5 hash? And then all you have to do is take that gigantic list and then go compare every value in the entire 175 million line log. And then you can go backwards to the taxi log. And that's a lot of data, but there's elastic MapReduce. I rented, I don't know, on Amazon 10 computers for like an hour. It took only 20 minutes. I didn't optimize the code at all. So in 20 minutes, you can go backwards and you can figure everything out. And here's an example of one of the lines. Those things are reversed into the medallion number and the taxi cab license number. And you can do this for the entire data set. And on top of this, there's publicly available information that will map all of the taxi license numbers back to the people's names. And because you have the values of every taxi trip, I can actually compute the gross income of every taxi driver in New York City in all of 2013. So this is really easy, and anyone who sort of has spent time thinking about this deeply could do this in like 2 hours. So what lessons do we have from this situation? First of all, never, ever, ever, ever hash to anonymize. You can't do it. It's bad. If you think, oh, I know how to do this, I'm going to hash it, like that's probably not the right answer. What you should do instead is, so another way they could have done this is for every taxi cab, you could generate a completely random number and then use that random number for every time that taxi cab is there. And then it would have been impossible to go backwards to the actual taxi ID number. Or you can encrypt it with a secret key. That's more complicated computer science, but basically it's equally good. But even that may not be sufficient because anonymizing data is really hard. There are a bunch of academic papers, I forget the names of the authors, who show that you can actually de-anonymize data relatively easily even if it has no personally identifiable information. And the London bike data that was released a couple of years ago is a good example. So because they know all the places where people go to and from, they were able to find one person's trips based on timing and all this stuff. So anonymizing data is really, really, really hard. And if you feel like you want to anonymize data, you should probably talk to an expert. There are a bunch of laws on this, I think, theoretically, but no one really knows. We are very lucky that this happened with taxi cab records and not with, for instance, student records. If they had tried to anonymize student records like this, it would have been a disaster because you could very easily find the names of everybody, common names of people in New York, and go backwards and figure out who they really are, that would have been catastrophic. Luckily here, we now know who the taxi cab ID numbers are. That's kind of bad, but at the end of the day, it's kind of not the end of the world. And so we have to do things that help the people who release these data know how to do this properly so that the next time it isn't about something that's more important for the privacy world and something that doesn't stop the movement towards increased open data. So yeah, any questions? Yeah. Sure, questions, yeah.
So I don't agree because
okay.
it is a privacy issue.
I don't disagree, it is, but it's much less of...
It's a big privacy issue.
It is a big privacy issue.
I have a hack license.
Yeah. I don't know what to tell you. It's pretty bad, and they released the data. It is a privacy issue. It is still not. It's not as much of it. So if they had released health records anonymized like this, like the UK is doing, the UK is doing better things to anonymize it. But the UK federal government has released health data records, and they're selling it to companies to do analysis. And there is a lot of concern about have you actually really anonymized this data correctly? And I agree. I mean, I would be pissed off if I had a hack license too, and if all of my data were revealed. However, at the end of the day, it's bad. I don't mean to say it's not, but compared to people's private health records, it's not as bad in the media, and that the media attention is the thing that can stop the open data initiative. But it's a really hard computer science problem to anonymize data. It's not trivial at all. And there are a lot of people who spend their PhD theses doing this, and it is a really complicated and challenging problem. And I don't mean to say that the person who did this is like an idiot by any means. It's if you haven't spent time thinking about it, and if you haven't worked with people who've explained this to you, it is not at all obvious when you look at this that this is what's happening, right? But it shows like how difficult it is to get this right. So, yeah. Yeah.
So there's a side issue here, which is the misinterpretation of missing data, right?
Yeah. Well, I mean that's like there's some data error in your data, right?
Well, right, but it came out looking like a person. So like in my line of work, we have a set of supermarket data, and the most popular brand is, or manufacturers, whatever manufacturer happens to have the code 00000.
Yeah.
Because for some reason these people didn't think to make that say missing, they assigned it to an actual brand, but it's not an actual brand, it's just whatever they leave it out.
Yeah.
You might also remember this Pornhub study of pornography habits by state, and the most popular state was Kansas. Well, why is that? It's because Kansas is the geographic center of the country, and whatever algorithm they're using when they left out a specific state is just found USA, and then it said, well, what state am I in? Kansas.
Yeah.
So I think that in looking at these things, you have to remember, it's not about the privacy side, but the analysis side. What happens to this?
It's a very good point, and before you jump to conclusions about data and when things don't make sense, it's probably bad data. It's a very good point, actually. It's astute observation. There was someone else had questions. Yeah.
Yeah, I have. It's twofold question. The first one: what's the political feedback, if I may call it that way? What's the process in which you'd tell them like, hey, you released that data, but I think it has a mistake and it has something we should fix. What's the process to go back to the government so that we don't affect the open data?
Well, so this is a complicated. So
They read it in the news.
yeah, they read it in the news. Actually, a friend of mine. So there are multiple issues. So if this data were available, had been available on the website of the city, this is a little bit of an easier maybe fix. It's not clear, but the problem is the data had been distributed, and thousands of people all over the world have this data, and it is it's not. It took me like 3 hours to do this, right? So it's not something. It's like anyone who knows what they're doing can do this trivially, and so I think in this case it's difficult. A friend of mine actually used to work at City Hall, and she said that there was someone there who was interested in talking about this. They don't have a commissioners or something set for the open data. So I don't know. So there may be a way to influence this. I think just like more understanding that when you release data that contains information about people. First of all, like, did you really need to release the taxi ID number? Like, why did the hack license number? I could understand the taxi ID number. Maybe you want to see what taxis are doing all day. But why do you care? Like, why are you releasing information about the drivers? That's like kind of strange, right? And maybe you randomize it in a reasonable way, and maybe you don't care. But even if you had randomized it, you know that taxi driver 47 starts every day at this location in Queens, and maybe that's his house, right? And so there are all these algorithms that you can use to go backwards. I'm not a political expert. I'm a software engineer, but I do feel like going and getting people who sort of see what's going on in the industry, and also have an in to the political world, can definitely make things fixed in some way. So cool. Hopefully you guys liked it. Feel free to grab me after if you have other questions.
Yeah, thanks.
Sorry, that one.